Section 6.1 is called mechanical losses. And mechanical losses, when we're talking about electrical machines, are comprised of three things, he tells us: bearing friction, brush friction, and something called windage. Let's look at each one of these individually and just define exactly what they are. Okay, so I've got the mechanical losses listed here, and you know, most of it's pretty straightforward, right? I mean, we understand what a bearing is in the motor. You know, it's where the you know, the shaft is seated in the bearing, and there's friction losses in the bearings. Depends upon the speed, the design of the bearings, so forth and so on. There's also brush friction, you know, where the on the commutator, the brush is actually set on the commutator, and there are friction losses there. You know, so any of this stuff that occurs, any of these losses that occur are going to cause two things, right? There's going to be you know, a heating and a loss of efficiency. So the increase in temperature and loss of efficiency. And then the one thing that might be sort of new to you, the term windage. Windage it's similar to friction, but it's the effect of air moving over something. And you know, it creates its own losses. Depends upon the speed and design of the cooling fan and the turbulence produced by the revolving parts. You know, these things are hard to measure directly. You know, so when we're going to quantify something like mechanical losses, you know, like this, we have to look at the system as a whole and input and output and make certain determinations that way. It's hard to, you know, determine them directly. And then he goes on to say that rotating machines are usually cooled by an internal fan that's mounted on the shaft. And you know, we've seen that our whole lives, but maybe we hadn't thought about what it's actually doing. You know, and so as the machine rotates, it draws in cool air and blows it over the windings and expels it through vents, or maybe the enclosure is built with you know, fins to disperse the heat. So all of those things are very important in dissipating this heat. And you know, again, as I mentioned in 6.0, sometimes we underestimate or undervalue the effect that heat has in an electrical machine. And it's a big deal. And it has to do with how the machine is not only designed, but how it's operated, what we can do safely and without damaging the electrical machine. And, you know, more specifically, what we're going to call the insulation, because that is where this effect occurs, where damage can happen. And we're going to look at insulation classes and see how that determines the classification of the motor. This figure 6.1 is a totally enclosed, water-cooled, 450 kilowatt, 3,600 RPM motor. This guy, it's used for a hostile environment. Warm air inside the machine is blown upward and through a water-cooled heat exchanger. So this whole thing here is a heat exchanger. And it says after releasing the heat to a set of water-cooled pipes, kind of like a radiator, right? The cool air re-enters the machine by way of two rectangular pipes in the end bales, okay? So there's a way to return that cooled air back to the motor that way. The cooling air moves through this closed circuit, and the surrounding contaminated atmosphere never reaches the motor winding. So this thing is sitting right in some environment that you don't want the internal workings of this motor to be exposed to. But at the same time, you have to dissipate the heat, or this heat would build up and essentially destroy this motor. Okay, so that's 6.1, a little overview on mechanical losses.